You can save a lot of time and headache on your next exam when you see an integral problem like this one here. When you see two functions, say x cubed and e to the 4x to the fourth, multiplied together like this, your first instinct might be, you know what? I should try integration by parts because there are two parts of this integral. But what if I told you that going down that rabbit hole might not be the best way to go? Because if you just blindly see a problem like this and think that the integral has one and only one way to solve it, you're not only wasting precious time, but you're possibly making this way harder than it needs to be. So let me show you in a question like this, an even faster method. We're going to talk about what's called u-substitution. When you see a problem like this, I want you to notice something here. This particular integral is very interesting because x to the fourth and x cubed have something in common. Their powers are 1 apart from each other. Now that's very important because when you think about a derivative or an integral of a polynomial, remember that you're always changing the power of x by 1. So what if I told you here that if you took these two parts, x cubed and x to the fourth, and thought of one being the derivative of another, you can actually make this problem a lot simpler. Let's go ahead and dive into it. And if you haven't already, feel free to hit that subscribe button if you like this video. And feel free to leave comments down below. I want to hear about some of the integral challenges you guys have had, maybe some sample problems and whatnot. So with the u-substitution method, what we're going to do here, after I rewrite this problem, is take the full power of the e function, being the 4x to the fourth, and I'm going to assign it to a variable called u. And then if you were to take the derivative of both sides with respect to whatever variable you'll see, the left side having a derivative of u with respect to u itself would be du. You're left with just a differential du. It's just like taking the derivative of x with respect to x and you just get 1, right? Similarly, and you probably already know this, but on the right-hand side, when you take the derivative of 4x to the fourth with respect to the x variable itself, remember that you subtract 1 from the power, so now the power will be a power of 3, and whatever exponent you had before, you're going to multiply it by whatever's in front of x, giving you 16x cubed dx. Now the right-hand side's a dx and not a du because we took the derivative with respect to the x variable. So notice with the substitution method here, we're separating things on each side of the equation. One variable letter is on one side and one is on the other. But also notice something really interesting here. Do you see how when we did this, on the right-hand side of the du equation, you have this x cubed dx part. Do you see that in the original integral problem? That's super important because what's that going to allow us to do is, with the substitution method, instead of having this integral of two functions f of x and g of x being multiplied, it's going to look like a very simple function itself. But the problem is this 16 term, because the original function doesn't have a 16 in front of x cubed, does it? Well, the cool thing here is this is an equation, right? So we can actually just simply divide both sides by 16. This would give us 1 over 16 du equals x cubed dx. What this means is if you go ahead and substitute in for x cubed dx in the original integral above, you're introducing this 1 over 16 du. And now what happens is because e is now raised to the power of u and not 4x to the fourth, since we assigned 4x to the fourth to this new variable called u, you have this equation now that looks way simpler, doesn't it? You wouldn't do integration by parts on this. This almost looks like a polynomial integral, only you have the function e here. And you don't have to do this. It's a pretty easy integral, but I personally like to then bring out this 1 over 16 factor outside the integral, because if you remember, you can bring a constant out of an integral. And so now you have 1 over 16 times the integral of e to the u du. And if you remember, the integral of e to the power of x, or u in this case, is simply e to the x, or e to the u. Also remember, do not forget that when you take the indefinite integral here, meaning there are no limits on the integral itself, you must always introduce this constant term c at the end. Are we done? Well, not so fast. Your answer here has something written in terms of u, but the original problem needs to be written in terms of x. And this is why you then need to finally plug back in what u happens to be. Going back up here, remember that you assigned u to this 4x to the fourth term. And so when you go back down here and make your substitution back in for x, you get a final answer of 1 over 16 e to the 4x to the fourth plus c. And if you don't believe that the problem was solved this simply as your homework, feel free to take the derivative of this and see if you get the original integral itself. I hope you enjoyed this video. Leave a comment, tell me what you think. And if you haven't already, check out this calculus playlist. I'll be tackling integration by parts in some future videos, and I'll catch you later.